Around 300 million years ago, land was not the center of life. Water held the advantage. Across low continents, wetlands spread without interruption. These were not small marshes, but wide systems of shallow water, dense growth, and slow movement. Visibility was limited. Movement mattered more than speed. Beneath the surface, predators did not pursue, they waited. Bodies stayed low, eyes remained just above the waterline. Some skulls grew wider than the rest of the body. Jaws opened sideways rather than forward. Teeth interlocked in rows built for holding, not slicing. They were not reptiles in the modern sense, not fully like amphibians today either. They formed something earlier. Fossils show broken bones in place, not scattered. Skeletons overlap in positions that suggest struggle, not decay. Encounters happened quickly and at close range. These environments supported them for millions of years, far longer than any human system has existed, and yet almost nothing familiar remains. Their forms do not map cleanly onto modern animals. Their ecosystems do not match anything still active today. This was a world structured around water first and land second. In this journey, we focus on the forgotten swamp predators that dominated Earth long before dinosaurs. But before we begin, let me know where you're listening from tonight and what time it is there. It's always comforting to see how far these sleepy stories travel. Now, let's begin. Time moved differently then, not faster or slower, but held in a kind of steady balance where change came quietly and remained for long stretches. The surface of the earth was still arranging itself, continents drifting toward one another in a gradual convergence that would, over millions of years, form a single vast landmass. Coastlines stretched and folded, inland seas narrowed, and the spaces between lands slowly disappeared until much of the planet's terrain became connected, low, and continuous. Across this joined world, the climate settled into a persistent warmth. Moisture lingered in the air, not as storms that came and went, but as a constant presence that rarely lifted. Rain fell often, yet gently, feeding wide expanses of shallow water that had nowhere urgent to drain. Evaporation returned it to the sky, and the cycle repeated without disruption. Seasons existed, though their differences were softened, more like subtle shifts in light than sharp transitions. The land itself remained close to the level of the water. There were no broad, open plains of grass, no flowering plants reaching upward, and no birds tracing paths across the sky. Instead, the ground was crowded with older forms of vegetation, dense forests composed of towering ferns, rigid stems, and early seed-bearing plants that rose in clustered silence. Their textures were coarse, their growth thick, forming layered canopies that filtered light into a dim green glow below. Beneath these forests, the terrain rarely dried. Water collected in long channels and shallow basins, spreading outward until it blurred the boundary between land and liquid. Footing was uncertain, a mixture of soft soil, decaying plant matter, and slow-moving pools. Each step would have pressed into surfaces that yielded slightly, holding impressions before gradually filling again. These wetlands did not exist as isolated pockets. They stretched across vast regions, linking together into continuous systems that defined the structure of the environment. Movement through them followed the logic of water rather than solid ground, guided by currents, depth, and the density of growth. Visibility remained limited, shaped by layers of vegetation and suspended particles that softened outlines and obscured distance. Life adapted to these conditions in ways that reflected the stability around it. Without the pressure of rapid environmental change, forms persisted, refining themselves slowly over immense spans of time. The absence of flowering plants meant that color remained muted, dominated by deep greens and dark browns. Without grasses, there were no open grazing spaces, no sweeping fields shaped by wind. The air carried the scent of damp organic matter, constant and unbroken. The merging of continents influenced more than geography. It allowed ecosystems to spread and connect, reducing isolation and creating broad shared environments. Rivers extended farther, floodplains widened, and lowlands remained submerged for longer periods. In these spaces, water was not an interruption to land, but its defining feature. Even the light felt altered within this world. Passing through dense foliage, it arrived softened and diffused, rarely striking the ground directly. Shadows were gentle, edges blurred, as if the entire landscape existed within a continuous filtered glow. This was the foundation upon which early complex life organized itself, not around dry land, but around water that lingered, spread, and endured. Stone holds its own quiet memory, pressed layer upon layer until time becomes visible in lines and weight. Within these layers, shapes begin to emerge, not as complete bodies at first, but as fragments that seem unfamiliar even to a trained eye. A curve that does not match any known spine, a surface too broad to belong to a skull as we understand it, patterns of bone that suggest something both grounded and hidden. As more of these remains were uncovered, a clearer form took shape, though clarity did not bring recognition. The skulls appeared unusually wide, extending outward far beyond the proportions seen in later animals. They did not taper forward in a streamlined way. Instead, they spread sideways, low and flattened, as if designed to rest just beneath the surface rather than move cleanly through open space. The top of the skull often appeared almost level, with only slight rises where the eyes were positioned. Those eyes sat high, placed near the upper surface rather than along the sides. Their orientation suggested a life spent with most of the body concealed, leaving only a narrow portion exposed above water. From this position, the surrounding world could be observed without revealing the full presence beneath. It is a structure that feels deliberate, shaped not for pursuit across distance, but for stillness and timing. The rest of the body followed this same quiet logic. Fossilized impressions indicate forms that remain close to the ground, with a weight distributed in a way that allowed them to settle into soft substrates. The spine extended behind the skull in a line that did not rise sharply, maintaining a low profile that blended easily with the environment it occupied. Movement, when it occurred, would not have lifted the body far from its resting plane. Limbs were present, yet they do not suggest long journeys across dry land. Their structure points to short, deliberate motions, capable of supporting the body for brief transitions or adjustments. The joints appear strong but not built for endurance. They could press against mud, push through shallow water, or guide the body forward in small advances, but not sustain continuous travel over distance. These characteristics place the creatures in an uncertain position within early attempts at classification. They shared traits with amphibians, yet did not fully align with any modern example. At the same time, certain features hinted at connections to groups that would later become more familiar, though the resemblance remained incomplete. They existed within a space that did not fit neatly into established categories. Early interpretations reflected this uncertainty. Some viewed them as oversized amphibians, while others proposed links to emerging reptilian forms. The fossil record offered no immediate resolution, only repeated patterns of the same unusual anatomy appearing across different regions and layers of rock. Each discovery added detail, but also deepened the sense that these animals belong to a chapter of life that does not extend cleanly into the present. As the bones continued to surface, a quiet consistency became apparent. The wide skulls, the elevated eyes, the low bodies, and the limited limbs all pointed toward a shared way of existing, not a single species, but a broader form repeated with variations. each adapted to similar conditions, yet distinct in subtle structure. What remains is not a perfect reconstruction, but a careful reading of what stone has preserved. These creatures reveal themselves not through complete images, but through patterns that, when seen together, suggest a life shaped by stillness, concealment, and proximity to the surface where water meets air. Names arrived long after the bodies had settled into stone, shaped not by the creatures themselves, but by those who studied their remains. As patterns became clearer, a term began to gather around them, one that would hold together many different forms under a single idea. They came to be known as temnospondyls, a name drawn from the structure of their vertebrae, where the internal segments appeared divided, layered in a way that set them apart from later animals. This label did not describe a single creature, but a wide and varied group that shared a common ancestry. Within it, forms differed in size, proportion, and detail, yet retained a recognizable framework that linked them together. The name offered a way to speak about them collectively, even as their individual differences continued to unfold through each new discovery. To understand where they fit, it helps to place them within an earlier stage of life on land, a time when the boundary between water and land had not yet been fully crossed. These animals are often described as early amphibians, though the word carries a meaning that has shifted over time. In this context, it refers to creatures that depended on water for key parts of their existence, even if they could move beyond it for brief periods. Their bodies carried this dual connection. Skin likely remained permeable, allowing moisture to pass through, which tied them closely to humid environments. Reproduction is thought to have taken place in water, where eggs could develop without the risk of drying. Early stages of life unfolded beneath the surface, before gradual growth brought them into larger, more capable forms. Freshwater systems provided the setting for most of their activity. Rivers, floodplains, and inland basins formed networks where these animals could live, feed, and reproduce. Unlike later groups that would expand into oceans or fully terrestrial spaces, temnospondyls remained anchored to these environments. The chemistry of fresh water, with its dissolved minerals and organic content, supported the processes that sustained them. Across different regions, their forms adapted to local conditions. Some species remained almost entirely within the water, their limbs reduced in function as their bodies became more streamlined for swimming. Others retained stronger limbs and could navigate the edges where water met land, moving slowly across soft ground before returning to the shallows. This variation allowed the group to occupy a range of ecological spaces within the same broader system. Despite these differences, they all represent an early expression of four-limbed life, a stage in which vertebrates were still refining how to support themselves outside of water. Limbs were present and functional, yet not specialized for speed or endurance on land. Movement remained cautious, shaped by the limitations of structure and the constant need to remain near moisture. The classification of temnospondyls reflects both what is known and what remains uncertain. They stand as a branch that flourished for a long span of time, contributing to the unfolding complexity of life without leaving a direct, simple continuation into the present. Their forms echo in later animals, yet do not resolve into any single modern lineage. In the quiet language of paleontology, the name endures, holding together a group that once moved through ancient waters in many different ways, unified not by identical shapes, but by a shared position within the long development of life on Earth. Individual forms begin to stand out when the broader group is viewed more closely, each one carrying its own proportions, its own balance between water and land, its own way of existing within the same ancient systems. What first appeared as a single kind of creature gradually separates into distinct bodies, each adapted with subtle precision. One of the more solidly built among them is Ariops, a form that suggests weight and strength held close to the ground. Its body appears dense, supported by limbs that are thicker and more capable than many of its relatives. These limbs were not shaped for speed, but for stability, able to press firmly into soft terrain and hold the body above it for short intervals. The skull, though still broad, carries a slightly more raised profile, giving the impression of an animal that could lift its head just enough to observe its surroundings beyond the immediate surface. Its structure suggests a life spent moving between shallow water and nearby land, never straying far from moisture, yet not entirely confined to it. In contrast, Mastodonsaurus presents a different emphasis, where the skull dominates the entire form. It extends outward in a wide, flattened plane, larger in proportion than most other parts of the body. The eyes sit near the top, aligned with the surface when the rest of the body remains submerged. The mouth opens with a reach that feels expansive, lined with teeth designed to secure rather than tear. Its limbs appear less suited for supporting extended movement and more for anchoring the body in place. This form suggests an existence almost entirely within the water, positioned near the surface, where stillness becomes a strategy and movement is reduced to brief, decisive actions. Another example, Metaposaurus, shares the broad-headed structure but introduces a different balance. Its skull remains wide, though slightly more compact, and its body appears adapted to environments where water is shallow and often shifting. The limbs are present, yet they seem arranged for managing soft, unstable ground rather than lifting the body high. Its overall shape suggests a life in areas where water levels fluctuate, where the boundary between submerged and exposed terrain changes gradually over time. It is a form suited to persistence within these conditions, maintaining contact with both water and the sediment beneath. When placed side by side, these creatures reveal differences that extend beyond simple size or shape. Ariops carries a sturdier frame, suggesting moments spent bearing weight on land. Mastodonsaurus leans toward a more submerged existence, with its massive skull defining how it interacts with its surroundings. Metaposaurus occupies an intermediate space, shaped by environments that are neither fully stable nor entirely submerged. These distinctions reflect variations in habitat as much as in anatomy. Some forms favored deeper channels, where water remained consistent, while others adapted to broader, shallower regions that changed with time. Body proportions shifted in response, with limb strength, skull width, and overall size adjusting to the specific demands of each setting. What becomes clear through these examples is that there was no single template. Instead, there existed a range of specialized forms, each one shaped by the same overarching conditions, yet refined in its own direction. Together, they form a quiet diversity, a collection of bodies that share a common origin while expressing it in different ways across the ancient wetlands they inhabited. Structure reveals intention in quiet ways, not through motion alone, but through how each part connects and supports the next. In these early forms, the body does not rise or stretch into open space. Instead, it spreads and anchors itself, every feature arranged with a certain economy, shaped by an environment where movement is measured and brief. The skull is the most striking element, not only for its width, but for how it functions. Rather than narrowing toward the front, it extends outward, creating a broad platform that allows the jaws to open across a wide arc. The hinge sits far back, giving the mouth a range that feels expansive without requiring speed. When it closes, the motion is direct and controlled, a single action that completes itself quickly. There is no need for repeated bites or complex chewing, only the ability to secure what enters that space. Along the edges of the jaws, the teeth are arranged in rows that interlock when the mouth closes. They are not shaped for cutting or grinding. Instead, they are slender, pointed, and slightly curved, designed to hold firmly once contact is made. Some extend longer than others, fitting into spaces along the opposing jaw, creating a structure that prevents escape. The pattern suggests a reliance on grip rather than processing, where the act of capture is final in itself. Behind the skull, the neck connects with a strength that appears disproportionate to its length. It does not need to lift the head high or support extended movement. Its role is more sudden, providing the force required for a rapid forward motion. The muscles would have been arranged to deliver a short, powerful surge, transferring energy from the body into the jaws in a single, coordinated action. This connection between head and body forms a continuous line of force, efficient and contained. The body itself follows this same principle. It remains low, with a broad torso that distributes weight across a larger area. This shape allows it to settle into soft ground without sinking too deeply, maintaining contact while still permitting movement when needed. The spine runs steadily through this form, not rising into pronounced curves, but maintaining a level alignment that keeps the entire structure close to the surface. Limbs extend outward from this body in a way that emphasizes pushing rather than lifting. They are sturdy, with joints that allow for controlled pressure against mud and shallow water. Instead of long strides, movement would have come from slow, deliberate presses, shifting the body forward in short distances. These limbs could also anchor the animal in place, holding it steady against gentle currents or minor disturbances in the surrounding environment. Positioned across the upper surfaces of the head are the sensory features that connect the animal to what lies just beyond its immediate reach. The eyes, placed high, allow for a narrow view of the space above, while most of the body remains concealed. Around them, subtle channels and openings in the bone suggest pathways for detecting changes in the water itself. Vibrations, slight displacements, and movements at the surface could be sensed before they were seen, creating a perception that extends outward without requiring visible motion. Together, these elements form a body that does not rely on speed or endurance. It is built for stillness interrupted by brief action, where structure replaces constant movement, and each part contributes to a single, cohesive way of existing within the quiet, shifting boundaries of water and earth. Stillness in this world was not an absence of activity, but a condition filled with quiet readiness. Beneath the surface, the body remained composed, each part held in a kind of suspended balance. Energy was not spent wandering or searching. It was stored, waiting for a signal that would pass through water before it could be seen. That signal came in subtle forms, a slight displacement, a pattern of ripples, a disturbance that traveled outward in soft waves. Water carries these movements with clarity, allowing them to reach sensitive structures along the head and body. Fine channels within the skin and bone, part of a lateral line system, could register these changes as faint pressure differences. In this way, the animal perceived motion not as an image, but as a shifting pattern in the medium around it. The response was not gradual. Once a threshold was reached, the body shifted from stillness into action with remarkable speed. Muscles along the neck and torso contracted in a coordinated sequence, pushing the head forward in a short, forceful surge. There was no extended chase, no adjustment in direction over distance. The movement was immediate, directed, and complete within a fraction of time. As the head advanced, the jaws opened along their wide arc, creating a space that expanded sideways rather than forward. This motion increased the area through which prey could be drawn in. The closing that followed was just as rapid, the upper and lower jaws meeting with precision, teeth interlocked, securing whatever had entered between them. The entire sequence, from detection to capture, occurred as a single continuous action, leaving little opportunity for escape. Shallow water played a quiet but important role in this process. In deeper environments, movement could disperse in multiple directions, making it less predictable. Near the surface or along the bottom, however, space was more constrained. Prey passing through these areas had fewer paths available, their motion guided by the contours of the environment. This created zones where encounters became more likely, not through pursuit, but through positioning. Within these zones, the predator remained aligned with the boundaries that shaped movement. The body settled close to the substrate, while the upper portion of the head stayed near the interface between water and air. This placement allowed it to monitor both the disturbances within the water and the subtle changes above it. The combination of sensory input and physical positioning created a narrow window in which action would occur. Once captured, the process continued without delay. The structure of the teeth, suited for holding rather than cutting, suggests that prey was not processed into smaller pieces. Instead, it was likely maneuvered within the jaws and guided toward the throat. Movements of the head and body could assist in this, using gravity and slight adjustments to align the prey for swallowing. The absence of chewing implies a reliance on the initial capture to determine success. Digestion would follow internally, where softer tissues could be broken down over time. This approach reduces the need for repeated feeding events, allowing long periods of stillness between successful captures. The body remains efficient, conserving energy until the next signal arrives through the water. In this way, hunting becomes less about motion across space and more about timing within it. The environment provides the pathways, the sensory system interprets the disturbances, and the body responds with a single, decisive action that completes the cycle in silence. Within these quiet systems, nourishment moved in steady cycles, carried through water and along its edges in forms both small and varied. What sustained these predators was not a single source, but a layered web of life that shifted gently over time, providing a continuous presence of potential prey. Fish formed the most consistent part of this pattern. Their bodies moved through channels and pools, following currents, seeking food, and reproducing in the same waters that supported everything around them. Many were armored or scaled, some with elongated shapes that allowed them to pass through dense growth, others broader and slower, feeding near the bottom. Their movements created the subtle disturbances that traveled outward, making them detectable even before they came into view. In this way, they became a reliable component of the diet, not because they were easy to catch, but because they were always present. Closer to the margins, where water thinned and met exposed ground, other forms appeared. Early land animals, still tied closely to moisture, moved cautiously along these edges. Their bodies were smaller, their movements careful, as they navigated terrain that was neither fully solid nor fully submerged. Some would pause at the boundary, entering shallow areas briefly before retreating. In these moments, they became part of the same cycle, their presence adding to the range of available prey. Among these were smaller amphibians, forms that shared certain traits with the larger predators but existed at a different scale. They occupied nearby spaces, feeding on even smaller organisms, yet remaining vulnerable to those above them in the hierarchy. Early reptiles, still in the early stages of adapting to life beyond water, also appeared in these environments. Their movements were more deliberate, their bodies less dependent on constant immersion, yet they remained close enough to be encountered within these shared spaces. The presence of multiple predators within the same systems introduced a quiet form of competition. It was not expressed through direct confrontation in most cases, but through overlapping territories and shared resources. When one individual captured prey, others nearby might be drawn by the disturbance, creating moments where proximity increased. Fossil evidence suggests that such interactions occasionally left marks, bite impressions, preserved in bone, indicating encounters that extended beyond simple feeding. Over time, repeated patterns of feeding left traces that could be read long after the organisms themselves were gone. Accumulations of bones within certain layers of sediment suggest areas where activity was frequent, where remains settled in place rather than being scattered. Some bones show signs of partial digestion, their surfaces altered before being preserved, hinting at processes that occurred within the body before returning to the environment. These patterns do not point to random or infrequent feeding, but to a steady rhythm, one that matched the stability of the surrounding world. Prey moved through the same channels, gathered in similar regions, and returned in cycles that allowed predators to remain where they were, relying on the continuity of the system rather than seeking out new ground. In this setting, nourishment was not pursued across great distances. It arrived through movement already present, shaped by the environment itself. The predators, in turn, became part of that same flow, taking what passed within reach and leaving behind traces that would settle quietly into the layers below. Numbers are not written directly into the stone, yet patterns remain, quiet arrangements that suggest presence rather than exact count. When these patterns are viewed across many sites, a sense of scale begins to form, not as a single figure, but as a living distribution spread across space and time. Within the same ancient wetlands, more than one kind of these predators often existed together. Their remains appear in overlapping layers, sometimes within the same deposits, indicating that different forms shared the same systems rather than replacing one another in sequence. Each occupied a slightly different position, shaped by body size, structure, and preferred depth, allowing them to exist side by side without constant conflict. Some remained closer to deeper channels, others nearer to shifting margins, creating a quiet partitioning of space. This coexistence extended across wide regions. As the continents gradually came together into a larger landmass, freshwater environments became more connected, allowing these animals to spread far beyond a single isolated area. Fossils attributed to this group have been found across what are now separate continents, indicating that their range once covered vast portions of the connected world. The continuity of these environments allowed similar forms to appear in distant places, linked not by immediate contact, but by the shared conditions that shaped them. Within each region, the number of individuals present at any given time depended largely on the availability of water. Where wetlands remained broad and stable, populations could persist in greater density. Channels, floodplains, and basins provided space and resources that supported multiple individuals, each maintaining a position within the same system. In contrast, areas where water was more limited or variable would have supported fewer individuals, their presence shaped by the changing extent of suitable habitat. This balance between water and land influenced not only where these animals could live, but how many could be sustained. A larger body requires more energy, and in environments where prey moved in cycles, there was a natural limit to how many predators could be supported without disrupting that flow. As a result, populations likely remained distributed rather than concentrated, with individuals spaced across the landscape in a way that reflected the underlying structure of the ecosystem. Prey availability formed another layer of this balance. Fish and smaller animals moved through these systems in patterns that could support a certain level of predation without collapse. When predator numbers remained within this range, the system continued steadily, each part reinforcing the other. If too many predators occupied a single area, competition would increase, and some would shift to less crowded spaces or fail to persist. Evidence of this balance appears in the fossil record through the relative abundance of different species and the spacing of their remains. Some layers contain numerous individuals, suggesting periods of favorable conditions, while others show fewer traces, hinting at times when the environment supported less life. These variations reflect not sudden changes, but gradual adjustments in response to water levels, climate, and the movement of prey. Across the larger landscape, this distribution created a network of populations, each connected by similar conditions yet separated by distance. Movement between regions may have occurred over long spans of time, following the slow changes in waterways and terrain. In this way, the presence of these animals was both widespread and locally shaped, a pattern that repeated across the ancient world. What emerges is not a precise count, but a living arrangement, many forms sharing space, guided by the quiet limits of water, energy, and time. There is a quiet support that water provides, a kind of invisible lift that changes how a body meets the world. Within it, weight becomes less absolute, no longer pressing fully downward, but softened, distributed through the surrounding medium. For these early forms, this shift allowed structures that might struggle on land to function with ease beneath the surface. A broad body, held low and wide, could rest within water without bearing its full mass against the ground. The pressure that would otherwise strain limbs and joints was reduced, allowing movement to occur without the same effort required on dry terrain. Each motion became more fluid, guided as much by the resistance of water as by the force of muscle. Instead of lifting the body entirely, it could glide or press forward with subtle adjustments, conserving energy in the process. This difference shaped how movement was expressed. On land, uneven surfaces and gravity demanded continuous support and balance. In water, these demands softened. The body could remain partially suspended, its contact with the ground intermittent, its progress defined by gentle propulsion rather than sustained lifting. Even a short movement could carry it forward with efficiency, aided by the surrounding medium. Alongside this ease of movement, water offered a steady presence of nourishment. Within these systems, life gathered and circulated in ways that remained relatively consistent over long periods. Prey moved through familiar paths, returning to the same regions as part of their own cycles. This continuity meant that food did not need to be sought across wide distances. It arrived within reach, carried by patterns that repeated with quiet regularity. The presence of water also shaped the condition of the body itself. Skin that remained permeable required constant moisture to function properly. Without it, vital processes would be disrupted, surfaces would dry, and the delicate balance within the body would be lost. In water, this risk diminished. The surrounding environment maintained the necessary hydration, allowing the body to remain stable without additional effort. Reproduction followed this same dependence. Early life stages required conditions that protected developing forms from exposure. Eggs laid within water could remain surrounded by the medium that sustained them, preventing desiccation and supporting gradual growth. The transition from early stages to larger forms could unfold within the same environment, reducing the need for sudden changes in habitat. Even the chemistry of water contributed to this stability. Dissolved minerals, organic particles, and the constant exchange between sediment and fluid created conditions that supported both growth and survival. These elements were not evenly distributed across all environments, but within these wetlands, they formed a consistent backdrop that reinforced the presence of life. Land, by contrast, presented challenges that had not yet been fully resolved. The absence of constant moisture, the full force of gravity, and the variability of surface conditions made it a less reliable setting for these forms. While brief movement across it was possible, it did not offer the same continuity or support. In this way, water became more than a habitat. It was a framework that shaped every aspect of existence, from movement and feeding to growth and reproduction. Within it, these animals found not only the means to survive, but the conditions that allowed them to persist over immense spans of time, held within a world where fluid support and quiet stability defined the limits of life. Beyond the edge where water receded, the ground offered a different kind of resistance, one that did not yield or support in the same way. Movement here required the body to carry its full weight, each contact with the surface demanding strength and balance that had not yet been fully developed. The transition from water to land was not a simple step outward, but a shift into conditions that challenged every part of the body at once. Limbs, though present and functional, were not designed for extended travel across dry terrain. Their structure allowed for brief support, enough to lift and reposition the body over short distances, yet not for sustained movement. The joints could bear weight momentarily, but repeated use would have required more energy than the body could efficiently provide. Instead of a smooth, continuous stride, motion would have been uneven, marked by pauses and adjustments, as if each step needed to be considered before it was taken. The surface itself added to this difficulty. Without the buoyancy of water, the body pressed directly into the ground, encountering textures that ranged from soft and unstable to firm and irregular. Each variation required a different response, yet the limbs lacked the flexibility and endurance to adapt quickly. Progress became slow, not through hesitation, but through the physical limits of the structure. Alongside these mechanical challenges, the condition of the body remained closely tied to moisture. The skin, permeable and responsive to its surroundings, depended on a humid environment to maintain its balance. On land, exposure to open air introduced a gradual loss of water from the body, a process that could not be easily controlled. As moisture diminished, essential functions would begin to falter, creating a boundary that could not be crossed for long. This connection to water extended inward as well. Physiological processes that operated smoothly in a saturated environment became less stable in dry conditions. The exchange of gases, the regulation of internal fluids, and the overall maintenance of the body all relied on a level of moisture that land could not consistently provide. Each moment spent away from water carried a quiet cost, one that accumulated over time. Food availability also shaped these limits. On land, the range of potential prey remained narrow. Early terrestrial ecosystems had not yet developed the diversity and abundance seen in later periods. Small organisms existed, moving through the same humid margins, but they were scattered and less predictable. Unlike the steady movement of life within water, these sources of nourishment did not follow clear pathways that could be relied upon. As a result, the effort required to find food on land often exceeded the benefit gained from it. searching across dry terrain demanded energy, while the chances of encountering suitable prey remained uncertain. In contrast, returning to water restored access to more consistent resources, reinforcing the connection between survival and the aquatic environment. These factors combined to create a natural boundary, not a sharp line, but a gradual limit that shaped behavior. Movement onto land occurred, yet it remained brief and purposeful, guided by necessity rather than preference. The body could cross this threshold, but it could not remain there for long. In this way, land existed as an extension of the environment rather than a replacement for it, a space that could be entered and left, but not yet fully inhabited. A landscape like this did not present itself as a single continuous surface, but as a quiet arrangement of layers, each one shifting slightly in depth, texture, and form. What appears from a distance as one broad wetland resolves, upon closer view, into a network of subtle variations, where water gathers, moves, and recedes in patterns that repeat over long stretches of time. Near the surface, shallow pools spread outward in irregular shapes, their edges soft and undefined. These areas held still water, warmed by filtered light, where fine particles settled slowly to the bottom. The depth here was minimal, allowing bodies to remain close to the substrate, with only slight adjustments needed to move through it. The ground beneath these pools was often composed of compacted organic material layered over time, creating a surface that could support weight without fully solidifying. Beyond these shallow spaces, deeper channels traced quiet paths through the landscape. These were not rapid or forceful currents, but slower movements of water guided by slight changes in elevation. Within these channels, depth increased gradually, providing regions where movement could extend below the surface without immediate contact with the ground. The boundaries between shallow and deep were not abrupt, but gently sloped, allowing for continuous transition between different levels. At intervals, the entire system expanded through flooding. Seasonal changes in rainfall or upstream flow caused water to rise and spread across areas that were otherwise only partially submerged. During these periods, boundaries dissolved, pools merged with channels, and new pathways formed across the terrain. As the water receded, it did not always return to its previous configuration. Sediment shifted, plant matter accumulated in new patterns, and the shape of the land adjusted slightly, creating a landscape that was both stable and slowly evolving. Vegetation played a central role in shaping these spaces. Dense growth extended across much of the surface, with stems and fronds forming layered structures that filtered light and movement. Visibility within these environments was limited, not only by the water itself, but by the physical presence of plant life. Open areas were rare, and even where water appeared clear, overlapping growth created a sense of enclosure. Within this complexity, smaller regions formed, each with its own conditions. Some areas remained consistently shallow, with soft sediment and dense vegetation. Others held slightly deeper water, where movement could occur with less resistance. There were places where plant growth thinned, allowing more light to reach the bottom, and others where decaying material accumulated, altering the texture and chemistry of the environment. These microhabitats existed side by side, separated by only small changes in depth or structure, yet distinct enough to support different forms of life. An organism adapted to one of these spaces might not move far beyond it, while another could shift between them as conditions allowed. This variation created a layered ecosystem where multiple forms could exist within the same broader swamp without directly overlapping in every aspect of their behavior. The overall structure was neither fixed nor chaotic. It followed patterns shaped by water, plant growth, and sediment, repeating with slight variations over time. Each part contributed to the whole, forming an environment that was continuous yet detailed, stable yet quietly changing, held together by the persistent movement and presence of water. Not all water within these ancient systems moved freely or carried the same clarity. In many places, it settled into slow, enclosed spaces where circulation was limited and renewal came gradually. Within these still regions, the composition of the water itself shifted, becoming dense with dissolved material and reduced in the amount of oxygen available to breathe. Oxygen, carried into water from the surface and through gentle movement, does not remain evenly distributed when flow is restricted. In stagnant pools and quiet basins, it becomes depleted over time, consumed by the many processes unfolding within. Microorganisms, feeding on organic matter, draw upon this supply, reducing it further as they break down what has accumulated. For animals living within these conditions, survival depended on the ability to function even as oxygen levels dropped. The water also carried the remains of the surrounding vegetation. Leaves, stems, and fragments of plant life settled into the depths, forming layers of decaying material. This decomposition released compounds into the water, altering its chemistry and giving it a heavier, more opaque quality. The color would have darkened, light penetrating only a short distance before being absorbed or scattered by suspended particles. Within such environments, visibility was minimal. Shapes dissolved into shadows, outlines softened by the density of the medium. For creatures relying on sight alone, this would have presented a challenge, but these forms were not dependent on clear vision. Their sensory systems, tuned to subtle changes in pressure and movement, allowed them to perceive their surroundings through means less affected by the loss of light. Temperature, in contrast, remained more stable within the water than on land. The thermal properties of water allowed it to absorb and retain heat, reducing the fluctuations that occurred in open air. While surface conditions might shift between warmer and cooler periods, the deeper layers held a more consistent range. This stability created an environment where sudden changes were less frequent, allowing biological processes to proceed without abrupt disruption. To exist within these combined conditions required a set of adaptations that balanced multiple constraints. Respiration had to function in water with reduced oxygen, likely supported by both lungs and skin, capable of absorbing gases directly from the surrounding medium. This dual approach would have allowed these animals to remain submerged for extended periods, surfacing when necessary but not relying on constant access to air. The body itself had to tolerate the chemical composition of the water, including the byproducts of decomposition. Skin surfaces may have been resistant to irritation or damage from these compounds, maintaining their integrity even as they remained in continuous contact with the environment. Internal systems would have processed the intake of water and its dissolved substances, filtering and regulating what entered the body. Movement through such water also required adjustment. The density created by suspended material increased resistance, slowing motion and dampening sudden changes. This suited a mode of life where stillness dominated and action occurred only when necessary. The environment itself reinforced this pattern, making rapid, continuous movement less efficient. In these murky, low-oxygen waters, life did not diminish but adapted, finding ways to persist within conditions that might seem restrictive. The combination of chemical richness, limited visibility, and thermal stability formed a distinct setting. one that shaped both the form and function of the animals that lived within it, allowing them to endure where clarity and abundance were not always present. Growth did not arrive all at once in these animals, but unfolded in stages that remained closely tied to water from the very beginning. Their earliest forms likely existed as small, delicate bodies, newly emerged within the same environments that sustained their parents. At this stage, the connection to water was not a preference, but a necessity, as the conditions required for survival existed almost entirely within it. The initial phase of life would have been marked by features suited to a fully aquatic existence. Limbs, though present in early form, were not yet capable of supporting the body outside of water. Movement depended on gentle propulsion, guided by the surrounding medium rather than directed across solid ground. Respiration may have relied more heavily on structures that functioned efficiently in water, allowing these young forms to remain submerged for extended periods without the need to surface frequently. As growth continued, changes occurred gradually, each stage building upon the last without abrupt transformation. The body increased in size, bones thickening and strengthening as they developed. Limbs became more robust, their joints capable of bearing greater weight, though still limited in their range of motion. The skull expanded, taking on the broader proportions that would define the adult form, while the arrangement of teeth shifted into patterns suited for capturing larger prey. This process was not uniform across all individuals, nor did it occur at a fixed pace. Environmental conditions, availability of food, and subtle differences in habitat likely influenced how quickly each stage progressed. Some individuals may have reached larger sizes more efficiently, while others developed more slowly, their growth shaped by the specific conditions surrounding them. Fossil evidence provides quiet insight into these stages. Smaller specimens appear alongside larger ones within the same layers, suggesting that different phases of development coexisted within the same environment. The bones of younger individuals often show less ossification, their structures not yet fully hardened, while larger specimens display more complete and reinforced skeletal features. These differences reflect a continuum rather than distinct categories, a progression that can be traced through variations in size and structure. The dependence on aquatic environments remained strongest during the earliest stages of life. Without the stabilizing presence of water, the developing body would have faced conditions it was not yet equipped to manage. Moisture, temperature, and the availability of suitable food all contributed to this reliance, creating a setting where growth could proceed without interruption. Even as individuals matured and gained the ability to move briefly onto land, this connection did not fully disappear. The later stages of life still returned to water for essential processes, maintaining a link that had been present from the beginning. Growth, in this sense, was not a movement away from water, but an expansion within it, allowing the body to occupy a wider range of positions while remaining anchored to the same fundamental environment. Over time, these gradual changes produced the larger forms seen in the fossil record, bodies that carried the traces of their earlier stages within their structure. The progression from small, fully aquatic beginnings to more developed forms reflects a continuity that remained unbroken, a steady unfolding shaped by the conditions that surrounded them from the first moments of life. Time in this part of Earth's history did not rush forward in visible leaps. It unfolded in long, quiet intervals where change was present but rarely abrupt. Within these intervals, certain forms remained not only intact but remarkably consistent, persisting through spans of time that extend far beyond familiar scales. The group to which these animals belonged endured for tens of millions of years, maintaining a presence across shifting landscapes and gradual environmental changes. Their bodies, already aligned with the conditions around them, required no rapid transformation to remain effective. Instead of frequent adaptation, there was refinement, small adjustments that accumulated slowly, almost imperceptibly, over immense durations. This stability reflects a close correspondence between form and environment. The wetlands and freshwater systems that supported them remained widespread and relatively consistent, providing the conditions necessary for their continued success. As long as these systems persisted, the fundamental design of the body did not need to change. The balance between structure and surroundings was already well established. Fossil records from different periods show this continuity with quiet clarity. Specimens, separated by long stretches of time, often display similar proportions and features, suggesting that the core body plan remained largely intact. Variations appear, but they do not represent sudden departures. Instead, they indicate gradual shifts in size, proportion, or detail, each one fitting within an already stable framework. Evolution, in this context, moved at a measured pace. Without strong pressures forcing rapid change, the process unfolded slowly, guided by subtle differences in habitat and resource availability. Some forms became slightly larger, others adjusted in shape or proportion, yet the overall design persisted. The wide skull, the low body, and the structure of the limbs continued to define their presence across generations. This long-term success also suggests efficiency. The body did not expend more energy than necessary, nor did it rely on complex or specialized features that required constant refinement. Its effectiveness lay in its simplicity, a design that met the demands of its environment without excess. Such efficiency allowed it to remain viable across changing conditions, as long as those changes did not disrupt the underlying structure of the habitat. The continuity of these forms across vast spans of time creates a sense of stillness within the larger movement of Earth's history. While continents shifted and climates adjusted gradually, these animals remained, their presence a constant within the broader transformation. They did not dominate through rapid expansion or dramatic innovation, but through persistence, maintaining their role within the ecosystems that sustained them. There is a quiet rhythm in this kind of endurance. Generations followed one another, each carrying forward the same essential structure, each existing within a world that, while slowly changing, remained familiar enough to support them. The passage of time did not erase them quickly, nor did it force them into sudden adaptation. Instead, they occupied a long, continuous chapter, one defined by stability rather than disruption. Their bodies, shaped early in this history, continued to function effectively across ages that stretched far beyond immediate perception, held within an environment that allowed them to remain largely unchanged. For a remarkable duration, a subtle shift began not in the water, but along its edges, where conditions allowed for a different kind of life to take hold. These new forms did not rely on the same constant immersion, and their presence marked a gradual change in how the landscape could be occupied. They moved with a quiet difference, not bound to the same limits, able to extend beyond the boundaries that had long defined the reach of earlier animals. Among these emerging groups were the early reptiles, forms that carried a structural and physiological departure from those that came before. Their bodies were shaped to retain moisture more effectively, reducing the constant exchange with the surrounding environment that had once tied survival so closely to water. This shift alone allowed them to remain on land for longer periods, moving across surfaces that would have imposed greater strain on earlier forms. One of the most significant changes appeared in how they reproduced. Instead of returning to water to lay eggs that required a surrounding fluid medium, these animals developed eggs encased in protective layers. Within these structures, the developing embryo remained enclosed in its own controlled environment, supplied with the necessary resources to grow without direct contact with external water. This innovation allowed reproduction to occur on land, removing a central dependency that had shaped life for millions of years. With this change came an expansion into areas that had previously remained largely unoccupied. Drier regions, where moisture was present but not constant, became accessible. The ground in these places offered firmer support, and the absence of standing water created different patterns of movement and resource distribution. Early reptiles moved through these spaces with increasing ease, their limbs and body structure supporting longer travel across varied terrain. Their presence did not immediately displace the established inhabitants of wetlands and shallow waters, but it introduced a new layer of interaction. As these reptiles moved along the margins and into adjacent environments, they encountered resources that had once been available without competition. Small animals, insects, and other forms of life that occupied transitional spaces became part of their range, expanding the network of feeding relationships. This expansion also altered the balance between environments. Where water had once defined the primary center of activity, land began to support its own developing systems. These systems did not replace the older ones, but they grew alongside them, creating a broader and more complex distribution of life across the landscape. The advantage held by these early reptiles was not rooted in speed or size alone, but in flexibility. Their reduced dependence on water allowed them to move between regions, to explore and occupy spaces that remained beyond the reach of those still tied to constant moisture. Over time, this flexibility would allow them to adapt to a wider range of conditions, gradually extending their presence. In contrast, the earlier forms continued within their established environments, where their structures remained effective and well suited. The wetlands still supported them, providing the conditions that had allowed their long persistence. Yet beyond these spaces, a different pattern was forming, one that did not require the same continuous connection to water. This quiet emergence of new competitors did not bring immediate change, but it introduced a direction in which life could move, expanding outward from the margins and reshaping the balance between water and land. Change did not arrive as a sudden replacement, but as a widening of possibility, a gradual extension of life into spaces that had once remained quiet. Along the margins where water met firmer ground, movement became more frequent, not only as brief crossings, but as a sustained presence that began to take hold beyond the reach of constant moisture. More animals began to occupy these drier areas, each carrying small adaptations that allowed them to remain there for longer periods. Their bodies retained water more effectively, their movement across uneven terrain became steadier, and their reliance on submerged environments lessened. Over time, these traits accumulated across different groups, creating a growing community of organisms that could exist without returning immediately to water. As this presence increased, the structure of life beyond the wetlands began to organize itself. Food chains formed within these emerging terrestrial spaces, linking small organisms with those that fed upon them in patterns that differed from those within water. Insects and other invertebrates moved through leaf litter and low vegetation, providing a new source of energy that could be accessed without entering aquatic systems. Small vertebrates followed, feeding on these organisms and establishing new layers within the developing network. This shift did not eliminate the importance of water, but it redistributed it. Instead of being the central stage for nearly all interactions, water became one part of a broader system. The edges that once served as boundaries now acted as connections, linking aquatic and terrestrial environments through overlapping zones of activity. Movement between these zones remained possible, yet the balance was beginning to change. For the larger aquatic predators, this change unfolded slowly, almost imperceptibly at first. The systems they relied upon continued to function, and the cycles of life within them remained largely intact. Yet, as more organisms established themselves outside of water, the proportion of available prey within aquatic environments began to shift. Some forms that had once remained near the edges now spent more time on land, reducing their presence within the reach of these predators. At the same time, new predators emerged within the terrestrial spaces, occupying roles that had no direct counterpart in the water. These animals hunted within the developing food chains on land, drawing energy away from the aquatic systems and redistributing it across a wider landscape. The result was not a sudden loss, but a gradual dilution of dominance, where no single environment held the same level of central importance as before. The wetlands continued to exist, their structure still capable of supporting life in familiar ways. Yet they were no longer the only place where complex interactions occurred. Beyond them, parallel systems were forming, each with its own rhythms and connections, expanding the overall network of life. This process did not involve conflict in a direct sense, but rather a quiet rebalancing. As life diversified across different environments, the influence of any one group became more limited. The large aquatic predators remained part of this world, yet their role began to shift from central to shared, as other forms established themselves in places that had once remained beyond reach. In this widening landscape, the boundaries between environments softened, and the patterns of life grew more varied, reflecting a slow transition toward a more distributed and interconnected world. The balance that had held for so long began to shift in ways that were not immediately visible, but gradually altered the rhythm of the world. Subtle changes in climate unfolded across vast regions, adjusting the patterns of moisture and temperature that had once remained steady. These shifts did not arrive all at once, but accumulated over time, reshaping the conditions that had supported life in quiet, persistent ways. In some areas, the air carried less moisture than before. Periods without rainfall extended, allowing surfaces to dry more fully between cycles of water return. The ground, once consistently damp, began to harden in places, its texture changing as moisture withdrew. These changes did not affect every region equally, but where they occurred, they introduced a new variability into environments that had long been defined by stability. Seasonal differences, once softened by constant humidity, became more pronounced. Warmer intervals brought increased evaporation, drawing water upward and leaving behind reduced levels in pools and channels. Cooler periods followed with less regularity, creating a rhythm that was less predictable than before. The transitions between these phases became more distinct, shaping the timing of biological processes that depended on consistent conditions. As these seasonal patterns intensified, the water systems themselves began to respond. Shallow areas that once remained filled for long durations now fluctuated more noticeably, expanding and contracting in response to changing inputs. Some pools diminished during drier intervals, their surfaces retreating and exposing underlying sediment. Channels that had once carried steady flow became intermittent, their continuity interrupted by periods of reduced water movement. This instability affected not only the extent of water, but its distribution. Areas that had been connected through continuous wetlands became more fragmented, with isolated pockets replacing broader expanses. Movement between these pockets required navigating across increasingly dry terrain, introducing new challenges for organisms that depended on constant immersion. The chemical and physical properties of the water also shifted with these changes. Reduced volume, concentrated, dissolved materials, altering the composition of the remaining pools. Temperature fluctuations, though still moderated by the presence of water, became more noticeable as the depth decreased. These variations introduced additional pressures on the organisms within, requiring adjustments that were not previously necessary. For those adapted to stable, persistent wetlands, these changes represented a gradual narrowing of suitable conditions. The environments that had once provided continuous support now required closer alignment with shifting patterns. Timing became more important as access to water and resources depended on phases that no longer remained constant. At the same time, regions that experienced less reduction in moisture continued to support familiar conditions, creating a contrast between areas of stability and those undergoing change. This variation across the landscape introduced new gradients where life responded differently depending on local circumstances. The overall effect was not immediate disappearance, but a slow reconfiguration of the world's structure. Water remained present, yet its reliability diminished in certain regions, altering the foundation upon which earlier systems had been built. What had once been continuous became variable, and what had been predictable began to shift with increasing range. In this gradual transformation, the conditions that had supported long-term persistence began to loosen, setting the stage for further changes that would continue to reshape the balance between water, land, and the life that moved between them. The continuity that once held these wetlands together began to loosen, not through a single event, but through a gradual thinning of connections that had long sustained them. What had been wide, uninterrupted systems started to contract, their edges pulling inward as water receded from certain regions. The landscape, once defined by expansive networks, shifted towards smaller, separated pockets. As water levels declined in some areas, the broad stretches that had linked pools and channels became interrupted. Shallow passages that once allowed movement between regions dried or narrowed, breaking the continuity of the system. What remained were isolated sections, each holding its own reduced body of water, no longer part of a larger, seamless environment. Within these shrinking spaces, conditions changed in subtle but significant ways. Depths became shallower, and the margins between submerged and exposed ground grew more defined. The gradual transitions that had once allowed easy movement between different areas became sharper, requiring more effort to cross. Organisms that depended on these connections found their range restricted, their movement limited to smaller regions. The loss of continuity affected reproduction as well. Areas that had once provided stable conditions for early development became less reliable. Fluctuating water levels introduced uncertainty, as pools that seemed sufficient at one moment could diminish before the next stage of growth was complete. The timing of reproduction, once aligned with consistent environmental patterns, now had to contend with conditions that varied more widely. For species whose life cycles depended on water at every stage, this instability created a narrowing window in which development could occur successfully. The availability of suitable breeding environments became uneven, with some regions still offering support while others no longer did. This uneven distribution introduced variation in survival rates, shaping populations in ways that reflected the changing landscape. As habitats contracted, The number of individuals occupying each remaining area increased relative to the available space. What had once been a broad distribution across connected wetlands became a concentration within smaller zones. This concentration brought different forms into closer proximity, increasing the likelihood of overlap in their use of resources. Competition emerged not as a sudden conflict, but as a gradual intensification of shared demands. Food sources, already shaped by the same environmental changes, became more limited within these confined spaces. The presence of multiple predators within a reduced area placed additional pressure on prey populations, altering the balance that had once remained stable. At the same time, interactions between predators became more frequent. Encounters that might once have been rare, due to the distance between individuals, occurred with greater regularity. These interactions did not always result in direct conflict, but they reflected a shift in how space was shared, where boundaries were no longer defined by wide separation but by immediate proximity. Across the landscape, this process unfolded unevenly. Some regions retained more of their original structure, while others experienced greater fragmentation. The result was a mosaic of environments, each reflecting a different stage of change, connected less by continuous water and more by the memory of what had once been. In this quiet reconfiguration, the wetlands did not vanish entirely, but they lost the cohesion that had defined them. Their structure became divided, their stability reduced, and the conditions that had supported long-term persistence began to fragment into smaller, less predictable forms. Size, which had once offered stability and quiet advantage, began to carry a different weight as conditions continued to shift. A large body, spread low and broad, required a certain consistency in its surroundings, a steady presence of water, space, and nourishment. As these elements grew less predictable, that same size became more difficult to sustain. The energy required to maintain such a body remained constant, yet the availability of food no longer matched it as reliably. Prey, once moving through familiar pathways in sufficient numbers, became less concentrated within the shrinking systems. Their distribution shifted, following the changing patterns of water and habitat. For a large predator, dependent on encounters within a defined range, this meant longer intervals between successful captures. With fewer opportunities to feed, the balance between energy intake and expenditure became more fragile. Each movement, though still measured, carried a cost that could not always be offset. The body, designed for efficiency within stable conditions, did not easily adjust to these fluctuations. It remained effective in form, yet increasingly challenged by the variability of its environment. Mobility also played a role in this emerging pressure. Larger bodies, while capable of controlled movement within familiar terrain, lacked the flexibility to adapt quickly to changing conditions. When water levels dropped or habitats became fragmented, relocation required crossing areas that offered little support. Short limbs and a low posture, once suited to specific environments, limited the ability to move efficiently across new or less favorable ground. In contrast, smaller organisms could adjust more readily. Their reduced size required less energy, and their movement across varied terrain was less constrained. They could navigate between shrinking habitats with greater ease, accessing resources that remained out of reach for larger forms. This difference in flexibility introduced a subtle imbalance where survival became increasingly tied to the ability to adapt quickly. The structure of the environment amplified these effects. As wetlands divided into smaller sections, the space available for each individual decreased. For large predators, which required broader areas to encounter sufficient prey, This reduction in space further limited their opportunities. The concentration of individuals within confined regions also increased competition, not only among similar forms, but across different species, occupying overlapping roles. These pressures did not act in isolation. Reduced prey availability, limited mobility, and shrinking habitats combined to create a cumulative effect. Each factor reinforced the others, gradually narrowing the range of conditions in which large predators could persist. What had once been a stable and supportive environment became a series of constraints that the existing body plan was not fully equipped to overcome. The change was not immediate, nor did it affect all individuals at once. Some regions may have continued to provide suitable conditions for longer periods, allowing populations to persist where stability remained. Yet, across the broader landscape, the trend moved toward increasing difficulty, where the advantages of size were slowly replaced by its limitations. In this evolving balance, the same features that had supported long-term success began to align less closely with the world around them. The environment shifted in ways that favored adaptability over stability, and in doing so, it placed growing pressure on forms that had once thrived within a more consistent and predictable system. The shift that followed did not resemble the gradual changes that had come before. It unfolded on a different scale, where multiple systems began to fail within a relatively short span of time. Across the planet, conditions that had once changed slowly now altered with increasing intensity, creating a cascade that moved through air, water, and land together. This period is known as the Permian mass extinction, the most extensive loss of life recorded in Earth's history. Entire groups disappeared, and ecosystems that had persisted for millions of years were disrupted in ways that did not allow for easy recovery. The transformation was not limited to a single region or environment, but extended across oceans and continents alike. In the oceans, changes in chemistry reduced the availability of oxygen within deeper waters. Circulation patterns weakened, limiting the exchange between surface and depth. As oxygen levels declined, many marine organisms were no longer able to survive in their usual habitats. At the same time, increased levels of dissolved carbon compounds altered the balance of the water, making it more difficult for certain forms to maintain their internal processes. The atmosphere above also shifted. Large releases of gases, likely driven by volcanic activity on a vast scale, introduced significant amounts of carbon dioxide into the air. This increase affected temperature and climate, leading to warming that extended across wide regions. The balance between heat absorption and release became altered, changing patterns of weather and precipitation. As temperatures rose, evaporation increased, further reducing available surface water in some areas. The hydrological cycle, once relatively stable, became more variable, with changes in rainfall distribution and intensity. Regions that had supported consistent moisture experienced longer dry intervals, while others faced different forms of instability. These combined effects created a feedback system, where changes in one part of the environment reinforced changes in another. Reduced oxygen in water affected marine life, while atmospheric changes influenced temperature and moisture, which in turn altered terrestrial and freshwater systems. The interconnected nature of these processes meant that disruption in one area could propagate outward, affecting others in succession. On land, vegetation patterns shifted as conditions became less favorable for existing plant life. As plant cover changed, so too did the availability of food and shelter for the organisms that depended on it. This further contributed to the breakdown of established ecosystems, reducing the stability that had once supported a wide range of life. For freshwater environments, these broader changes translated into increasing instability. Variations in temperature, water availability, and chemical composition created conditions that were more difficult to sustain over time. Systems that had already been fragmenting faced additional pressure as the underlying factors supporting them continued to shift. The pace of these changes, while still unfolding over thousands of years, was rapid in comparison to the long periods of stability that had preceded them. Life that had adapted to gradual variation now encountered conditions that altered more quickly than many forms could accommodate. In this convergence of environmental shifts, the world entered a period where persistence became increasingly difficult. The structures that had supported long-term continuity gave way to a landscape defined by rapid transformation, where survival depended on the ability to endure conditions that no longer followed familiar patterns. Survival in quieter ages had depended on alignment, a close fit between body and environment that required little adjustment once established. When that alignment began to break, the same features that once ensured persistence became less able to respond. The change did not come from a single weakness, but from the accumulation of limits that could not be overcome within the time available. These creatures remained closely tied to water in nearly every aspect of their existence. Their bodies depended on constant moisture, their movement was shaped by it, and their early development could not occur without it. When water systems became unstable and fragmented, this dependence narrowed the range of places where they could continue to live. Habitats that had once supported them steadily now fluctuated or disappeared, reducing the continuity they required. Unlike forms that had begun to move more freely across land, they could not easily shift into new environments. Their structure, refined over long periods of stability, did not allow for rapid adjustment. Limbs were not suited for extended travel across dry terrain, and physiological systems remained linked to conditions that were no longer consistently present. Movement between shrinking habitats became more difficult, and the distances between suitable areas increased beyond what could be reliably crossed. The pace of environmental change also played a critical role. For millions of years, these animals had existed within conditions that altered slowly, allowing gradual adaptation to keep pace. During this period of disruption, however, changes occurred more quickly than their bodies could respond. There was little time for incremental adjustments to accumulate, and the existing form could not be reshaped fast enough to meet the new demands. At the same time, the networks of life that supported them began to unravel. Prey species, already affected by the same environmental pressures, declined or shifted into different regions. The steady flow of food that had once passed through familiar spaces became irregular, then scarce. With fewer opportunities to feed, energy balance became increasingly difficult to maintain, especially for larger individuals. This collapse of food chains did not occur in isolation. As prey diminished, competition intensified among those that remained. Smaller and more adaptable forms were able to exploit a wider range of resources, further reducing what was available within the specific niches these larger predators occupied. The system that had once supported a stable hierarchy began to reorganize, favoring those able to adjust quickly to new conditions. Reproduction also became more uncertain. With fewer stable environments available for early development, the likelihood of successful growth decreased. Each generation faced conditions less favorable than the last, reducing the continuity that had once allowed populations to persist across long spans of time. These pressures, combined into a gradual decline, not marked by a single moment, but by a series of reductions in number and range. Populations became smaller and more isolated, their ability to recover from local losses diminished. As conditions continued to shift, these isolated groups faced increasing difficulty in maintaining themselves. In the end, it was not a single cause, but the convergence of dependence, limited adaptability, and the breakdown of supporting systems that shaped their disappearance. Their bodies, once so well suited to a stable world, could not follow the rapid changes that redefined it, and within that widening gap, their long presence came quietly to an end. After the wider collapse had passed through air and water, what remained was not empty space, but a quieter collection of forms that had endured by fitting more loosely into their surroundings. These survivors did not rely on a single set of conditions. Their presence reflected a different balance, one shaped by flexibility rather than long-held stability. Among them were smaller organisms, whose size reduced the demands placed upon their environment. A smaller body requires less energy, less space, and fewer consistent resources to remain viable. This allowed them to persist within habitats that had become fragmented and unpredictable. Where larger forms needed continuous systems to sustain themselves, these smaller species could occupy isolated pockets, moving between them when conditions allowed. Their adaptability extended beyond size. Many could tolerate a wider range of environmental variation, enduring fluctuations in moisture, temperature, and resource availability that would have been more difficult for earlier forms. This tolerance did not eliminate challenge, but it provided a margin within which survival remained possible, even as conditions shifted. Early reptiles continued along this path, their development aligned with the changing world. Their ability to reproduce away from water allowed them to establish populations in regions that were no longer connected to stable wetlands. As water systems diminished in some areas, these animals expanded into the spaces left behind, occupying terrain that had once been marginal. Their bodies, already less dependent on constant moisture, supported this expansion. Skin that retained water more effectively, limbs capable of sustained movement across land, and internal systems suited to a broader range of conditions allowed them to move through environments that were becoming more varied. Over time, these traits supported further diversification as different forms adapted to specific aspects of the emerging landscape. With these changes came a shift in how ecosystems were organized. Food chains that had once centered around aquatic systems began to reassemble on land. Insects and other small organisms formed the base of these new networks, feeding on plant material and detritus that accumulated in drier environments. Small vertebrates followed, feeding on these organisms and becoming part of a growing web of interactions that no longer depended on continuous water. This transition did not remove water from the system entirely, but it reduced its role as the primary foundation for life. Instead, land-based ecosystems gained prominence, expanding in both complexity and extent. Areas that had once supported only limited activity began to host a wider range of interactions, creating new pathways for energy to move through the environment. Within this shifting balance, the survivors were not necessarily those that had once dominated, but those that could adjust to changing conditions without requiring them to remain fixed. Their success lay in their ability to function across different environments, to persist even as the landscape continued to evolve. The world that followed was not a direct continuation of what had come before, but a reorganization shaped by the forms that remained and the conditions they could inhabit. In this new arrangement, adaptability became a defining feature, guiding the direction of life as it moved further onto land and into a broader range of environments, carried forward by those able to endure variation rather than depend on constancy. What followed was not an immediate renewal, but a quieter landscape, one in which many of the former connections had been reduced or lost. The world that remained carried traces of what had been, yet its structure had changed, becoming more open in some places and more sparse in others. Moisture, once widespread and consistent, now appeared in more limited forms, gathering in fewer regions and leaving broader areas exposed. The air itself held less of the softness that had once defined it. Periods without rain extended further, allowing surfaces to dry and harden. Soil that had been layered with organic material became more compact, its texture shifting as water withdrew. The boundaries between wet and dry grew more pronounced, shaping a landscape where conditions varied more sharply across short distances. Vegetation reflected these changes. The dense growth that had once filled the environment gave way in many areas to more scattered forms. Plants adapted to reduced moisture persisted, while others declined, leaving spaces that were less crowded and more exposed. The canopy, once continuous in many regions, opened in places, allowing light to reach the ground more directly. This altered not only the appearance of the land, but the conditions within it, affecting temperature and the distribution of life. Ecosystems within this altered world became simpler in their structure. Where once there had been multiple overlapping layers of interaction, fewer connections now remained. Food chains shortened, with fewer steps linking the smallest organisms to larger ones. Each part of the system carried more direct influence over the others, as the complexity that had once buffered change was reduced. This simplification did not imply absence, but rather a reduction in diversity and interaction. The forms that persisted were those able to function within these new limits, maintaining their presence without relying on the broader networks that had previously supported them. The relationships between species became more direct, shaped by the availability of resources within a narrower range of conditions. Recovery, when it began, did so gradually. New growth appeared in small increments, filling spaces where conditions allowed. Over time, these increments accumulated, introducing variation back into the system. Different forms began to establish themselves in the altered environment, each contributing to the slow rebuilding of connections. This process unfolded over long spans, measured not in immediate change, but in the gradual return of complexity. Areas that remained stable for extended periods allowed new interactions to form, while regions still experiencing variability continued to limit what could persist. The landscape did not return to its previous state, but moved toward a different configuration, shaped by the conditions that now defined it. Water, though reduced in some places, remained present, continuing to influence where life could gather and grow. Its distribution, however, no longer created the same continuous systems that had once dominated. Instead, it contributed to a more varied pattern, supporting life in certain areas while leaving others more exposed. In this quieter world, the pace of change slowed again, though the outcome differed from what had come before. The structures that emerged carried the imprint of disruption, forming new arrangements that reflected both the loss that had occurred and the gradual rebuilding that followed. Out of the quieter intervals that followed, new patterns of movement began to take shape, not within the remaining water systems, but across the expanding stretches of land. These movements carried a different rhythm, more continuous, less tied to specific boundaries, as certain groups developed bodies suited to a world where dry ground held increasing importance. Among these emerging forms were the early archosaurs, a group that would come to occupy a wide range of roles in the evolving landscape. Their presence was not immediate or overwhelming, but gradual, building over time as their characteristics aligned with the conditions that now defined much of the environment. They did not rely on constant proximity to water, allowing them to move through regions that had become less accessible to earlier forms. Their bodies reflected this shift. Limbs were positioned more directly beneath the body, supporting a posture that lifted the torso away from the ground. This alignment allowed for more efficient movement across land, reducing the energy required for each step. Rather than pressing outward against the surface, their limbs acted in a more vertical orientation, enabling longer and more sustained travel. This change in structure supported a broader range of behaviors. Movement could extend beyond short, deliberate motions, becoming more continuous and adaptable. These animals could navigate uneven terrain, cross greater distances, and respond more quickly to changes in their surroundings. Their bodies were not only suited to stability, but to motion across varied landscapes. Respiration and circulation also aligned with these demands. Systems within the body allowed for a steady supply of oxygen during extended activity, supporting movement that did not rely on frequent pauses. This internal efficiency complemented their external structure, creating a form capable of sustained interaction with its environment. As these traits developed, archosaurs began to expand into different ecological roles. Some forms occupied positions as active predators, moving across land in search of prey that had become part of the growing terrestrial food chains. Others adapted to different diets, feeding on available plant material or smaller organisms, contributing to the diversification of interactions within these systems. This expansion did not occur within a single environment, but across a range of conditions, from drier regions with sparse vegetation to areas where moisture still supported denser growth. These animals adjusted to local circumstances, developing variations that reflected the diversity of the landscape. Their ability to function across these different settings allowed them to spread widely, establishing a presence in many parts of the world. The emergence of these new dominant groups did not erase what had come before, but it marked a shift in where influence was centered. Land, once secondary to water, became the primary stage for complex interactions. The structures that supported life continued to evolve, shaped by forms that could move, feed, and reproduce within this expanding terrestrial domain. In this gradual transition, archosaurs became a defining element of the New World. Their bodies and behaviors aligned with the conditions that now prevailed. Their rise reflects not a sudden replacement, but a steady reorientation of life, guided by the changing balance between water and land, and carried forward by those able to move within it with greater freedom and range. Momentum once established in these emerging terrestrial systems continued to build as certain lineages refined their ability to move, endure, and spread. Among them, dinosaurs developed forms that carried this momentum further, aligning closely with the conditions that had come to define the post-extinction world. Their movement across land reflected a high degree of efficiency. Limbs were positioned directly beneath the body, creating a balanced structure that supported sustained motion with reduced energy loss. Each step transferred force in a controlled and forward direction, allowing for longer travel without the strain seen in earlier, more sprawling forms. This alignment also lifted the body away from the ground, reducing friction and enabling smoother progression across varied terrain. The internal systems of these animals complemented this structure. Breathing mechanisms supported a continuous flow of oxygen, maintaining activity over extended periods. This allowed movement that was not limited to short intervals, but could continue across longer distances, opening access to resources that lay beyond immediate surroundings. The coordination between body and physiology created a form capable of sustained interaction with the environment rather than brief engagement followed by rest. Adaptation to dry conditions further extended their range. Skin structures reduced water loss, maintaining internal balance even in regions where moisture was limited. Reproduction, already independent of water in earlier reptiles, continued in this lineage, allowing eggs to develop within protective shells on land. This removed the need to return to aquatic environments, freeing these animals to occupy spaces that had once remained beyond reach. These traits allowed dinosaurs to expand into a wide array of environments. Some moved through open landscapes where vegetation was sparse, while others occupied regions where plant growth provided more cover and resources. Their diversity increased as they adapted to different conditions, with variations in size, shape, and diet reflecting the range of habitats they inhabited. As they spread, they filled ecological roles that had become available after earlier disruptions. Predatory forms pursued prey across land with increasing effectiveness, while herbivorous species fed on the vegetation that had begun to reestablish itself. Each role contributed to the rebuilding of complex ecosystems, linking organisms together in new patterns that reflected the conditions of the time. This expansion did not occur as a single uniform process, but through gradual diversification. Different groups within the broader lineage developed distinct characteristics, allowing them to occupy specific niches. Some became specialized for speed, others for strength, and still others for particular feeding strategies. This variety reinforced their presence across the landscape, as no single environmental change could affect all forms equally. The success of these animals lay not only in individual traits, but in the combination of movement, adaptability, and ecological range. Together, these factors allowed them to persist and expand within a world that continued to shift, providing resilience in the face of ongoing change. In this way, dinosaurs came to occupy a central position within terrestrial ecosystems, their forms and behaviors aligned with the conditions that now defined life on land. Their rise reflects a continuation of the broader transformation that had been unfolding, where the ability to move efficiently, endure dryness, and adapt across multiple environments shaped the direction of life in the ages that followed. They do not fit easily into the shapes that exist today, and when their forms are placed beside modern animals, the differences remain clear, not as small variations, but as entire arrangements that no longer appear in the present world. Their bodies seem familiar in parts, yet the whole never fully aligns with anything still living. The skull, broad and flattened beyond what is commonly seen now, forms a shape that does not correspond to modern amphibians or reptiles. It spreads outward in a way that suggests a relationship with water, yet not in the streamlined sense of later aquatic animals. The placement of sensory structures, the pattern of bone, and the proportions of the head create a configuration that feels both purposeful and unfamiliar, as if it belongs to a pathway that did not continue. The rest of the body carries this same quality. Limbs are present, capable of supporting weight for brief intervals, yet they do not resemble the more refined structures seen in later terrestrial animals. Their orientation and strength suggest an intermediate function, not fully adapted for life on land, yet no longer limited to movement within water alone. This combination creates a form that exists between modes of existence, rather than within a single, defined one. Skin and physiology reinforce this position. Their dependence on moisture remains evident, yet their size and structure indicate a capacity for interactions that extend beyond simple aquatic life. They are not confined in the same way as earlier forms, but neither are they fully released from those constraints. This balance places them within a transitional space where traits from different stages of evolution coexist within a single organism. Such transitional forms do not always leave clear descendants. In some cases, they represent experiments in structure, arrangements that function effectively within specific conditions but do not extend into later lineages. The features that define these swamp creatures illustrate this kind of path, one that contributes to the broader development of life without continuing directly into modern equivalents. Their uniqueness also lies in how their parts work together. Each feature, from the skull to the limbs, aligns with a particular way of interacting with the environment. The combination creates a system that is internally consistent, even if it does not resemble what comes after. This coherence suggests that their design was not incomplete, but suited precisely to the conditions in which they existed. When compared to modern animals, there are echoes, but no direct matches. Certain amphibians retain aspects of moisture dependence, and some reptiles share structural traits, yet none replicate the full arrangement seen in these earlier forms. The differences are not only in detail, but in overall organization, reflecting a stage of evolution that has since diverged into other directions. Fossils preserve this distinctiveness with quiet clarity. The shapes remain, captured in stone, showing a pattern that appears repeatedly, yet does not lead forward in a straight line. Each specimen adds to the sense of a group that occupied its own place in the history of life, neither fully ancestral to modern forms nor entirely separate from them. In this way, these swamp creatures represent a moment in evolution where possibilities were explored in forms that no longer persist. Their bodies reflect a combination of traits that once functioned together within a specific world, leaving behind a record of structures that remain unique, without direct continuation, in the living systems that followed. Reconstruction begins not with complete forms, but with fragments arranged within layers that record the passage of time. Sedimentary rock preserves these layers, each one formed from particles that settled slowly through water or were carried across land before coming to rest. Within them, bones appear as quiet inclusions, held in place by the material that surrounded them at the moment of burial. The position of these remains provides the first clues. Bones found in articulation, where joints remain connected, suggest that the body came to rest with minimal disturbance. In other cases, scattered elements indicate movement after death, shaped by currents or shifting sediment. The texture of the surrounding rock, whether fine and compact or coarse and layered, reveals the conditions under which the material accumulated, offering insight into the environment in which the organism lived and was preserved. From these deposits, patterns emerge that extend beyond individual specimens. Repeated findings of similar forms within the same types of rock indicate environments that supported particular kinds of life. Layers associated with ancient river channels or floodplains often contain remains arranged in ways that reflect slow water movement, while deposits from quieter basins preserve more delicate structures, protected from disturbance. Among the most informative elements are the skulls, whose structure carries a detailed record of form and function. When fragments of skulls are recovered, they are studied closely, each piece examined for its shape, thickness, and points of connection. These fragments are then compared with others, sometimes from different locations, to determine how they fit together. Through this process, a more complete structure can be assembled, not always perfectly, but with increasing accuracy as more material becomes available. The arrangement of bones within the skull reveals relationships between different parts of the head, including the placement of sensory structures and the alignment of the jaws. Subtle features, such as grooves or openings, suggest pathways for nerves and vessels, indicating how the animal may have perceived its surroundings. These details allow scientists to move beyond simple shape, building an understanding of how the skull functioned as a whole. Advances in imaging have added further depth to this work. Techniques that allow internal structures to be viewed without damaging the fossil provide additional information about bone density and internal organization. These details contribute to a more complete picture, revealing aspects of the organism that would otherwise remain hidden. The broader landscape is reconstructed through the study of the rock itself. Ancient river systems can be traced by following the distribution of certain types of sediment, while the presence of organic material within layers suggests the existence of wetlands or flood zones. Patterns in grain size, layering, and mineral composition all contribute to an understanding of how water moved through these environments and how stable or variable they were over time. By combining these lines of evidence, a picture forms that extends beyond individual organisms. The arrangement of fossils within sedimentary layers, the structure of the bones themselves, and the characteristics of the surrounding rock all contribute to a reconstruction of the world in which these animals lived. It is a process that does not rely on a single discovery, but on the accumulation of many observations, each one adding to a larger, more detailed understanding. Through this careful assembly, the past is not recreated as a fixed image, but as a layered interpretation, shaped by evidence preserved within stone and refined as new discoveries continue to emerge. Attention often settles on forms that are easier to imagine, and over time, certain images become more fixed in collective memory than others. Large terrestrial animals with upright posture and clear outlines lend themselves to reconstruction in ways that feel immediate. Their shapes translate easily into illustrations, models, and stories, allowing them to occupy a more visible place in how the past is remembered. In contrast, the earlier inhabitants of wet environments remain more difficult to picture with the same clarity. Their bodies, shaped by conditions that no longer exist in the same way, do not align with familiar categories. Without a direct modern counterpart, their appearance requires a degree of interpretation that is less straightforward. The result is a quieter presence, not absent, but less often brought into focus. The fossil record contributes to this difference. Remains of these swamp-dwelling animals are frequently found in conditions that affect preservation. Soft, waterlogged sediments can shift before hardening into rock, altering the arrangement of bones or fragmenting them over time. As a result, many specimens are incomplete, requiring reconstruction from partial material. Each fragment adds information, yet the overall picture often remains less defined than that of animals preserved in more stable conditions. By comparison, later terrestrial environments sometimes provide clearer records. Sediments that accumulate in drier settings can preserve skeletal structures with less disturbance, allowing more complete forms to emerge. These more intact specimens offer a stronger foundation for reconstruction, making it easier to establish proportions, posture, and movement. With more complete data, the resulting images become more consistent, reinforcing their presence in scientific and public understanding. Visualization plays a quiet but important role in memory. When an organism can be reconstructed with confidence, its image becomes repeatable. It appears in books, exhibits, and visual media, each instance reinforcing recognition. Over time, this repetition creates familiarity, and familiarity supports recall. Animals that fit this pattern become central figures in the broader narrative of Earth's history. Those that are harder to reconstruct remain less frequently depicted. Their forms may vary between interpretations, reflecting the gaps in available evidence. Without a single, widely accepted image, they do not settle as firmly into shared awareness. Instead, they exist within more specialized contexts, studied in detail, but less often presented in a way that reaches beyond those focused on the field. This difference does not reflect a lack of importance, but a difference in visibility. The earlier dominance of these swamp creatures remains evident within the layers of rock where their remains are found, repeated across regions and time intervals. Their presence is recorded with consistency, even if their appearance is not as easily fixed in a single, familiar form. Cultural attention follows paths shaped by clarity, repetition, and ease of representation. As certain groups become more prominently featured, others recede, not because they were less significant, but because they are less easily translated into enduring images. The result is a history that feels uneven in its visibility, where some chapters are illuminated more brightly than others. Within this quieter space, the swamp creatures remain, preserved in fragments and reconstructions that continue to develop. Their forms may not be as widely recognized, yet they persist in the record, holding a place in the broader continuity of life, even when that place is less often brought into view. There is a quiet continuity that runs through Earth's history, a pattern in which dominance is never permanent, only held for a time before giving way to something new. The forms that once defined entire worlds can fade until only traces remain, not erased, but folded into layers that wait to be read with patience. The swamp systems that once stretched across ancient landmasses supported life in ways that no longer exist in the same form. Within them, creatures developed bodies and behaviors precisely suited to those conditions, shaping ecosystems that operated with their own balance and rhythm. These environments were not simple or incomplete, but deeply structured, with interactions that unfolded over immense spans of time. What has followed since does not replace that complexity, but builds upon a sequence of transformations. Life moves forward not as a straight path, but as a shifting arrangement where certain traits become more suited to changing conditions while others recede. Entire systems can contract, fragment, and disappear, carrying with them the forms that depended on them most closely. The rise of later dominant groups often draws attention because their shapes feel more familiar, their environments more recognizable. Yet the earlier worlds hold equal depth, even when they are less visible in modern imagination. Their differences invite a slower kind of understanding, one that does not rely on easy comparison, but on careful reconstruction and quiet observation. Fossils, preserved within stone, offer these glimpses without urgency. They do not present a complete image all at once, but reveal fragments that must be assembled over time. Each discovery adds to a larger picture, one that remains open to refinement as new evidence emerges. Through this process, the past becomes something that is not fixed but gently clarified. In considering these earlier forms of life, attention shifts away from what is most familiar and toward what is less often seen. The absence of direct modern equivalents does not diminish their significance. Instead, it highlights the breadth of possibilities that have existed, many of which no longer persist. These creatures occupied a world that was fully realized in its own time, even if it does not resemble the present. There is a quiet value in noticing what has been overlooked. The layers beneath more widely known histories hold their own narratives, shaped by environments that rose, stabilized, and eventually changed. Within those layers, patterns of life unfolded with consistency, leaving behind records that continue to inform how the broader story is understood. As this journey settles, what remains is not a single image, but a sense of continuity that extends beyond any one group or era. The world before dinosaurs was not a prelude waiting for something else, but a complete chapter rich with its own structures and forms. Its details continue to emerge slowly, carried forward by those who study and interpret the evidence left behind. If any part of this passage lingers, it becomes part of that ongoing reflection, a quiet addition to how these hidden histories are held. For those who find themselves drawn to these slower explorations of science, there is always more to uncover, more layers to move through, and more stories that unfold gently over time.